Oh, it's a comma. This is a comma. Okay, so if it's ionic, it's going to split into its pieces. Do you remember talking about that when we did the equations for lab 4? So this is going to, we're going to add it to water, it's going to break into its ions. So we know that ammonium is an H4 plus, and chlorine, we know, forms a Cl, it forms a minus charge, okay? I know it forms a minus charge because it's in the column right before the noble gases. Those want one more valence electron, and that's why it gets the minus charge, okay? And those are something that hopefully you have memorized already, but that's how we're gonna know that. So this is one that I have to memorize, and this is, we're kind of memorizing it, but it follows a pattern, okay? So in solution, we're going to have this piece. So it's going to be nitrogen attached to 4 hydrogens. And this molecule thing, this ion, has a plus charge. And then we have this chlorine atom and has a minus charge. So this is what we would be looking for. If it's in water, then we would also have water molecules floating around. Okay. So we need water, we need this ion, and we need this ion, okay? So that's what we'd be looking for if it's ionic. Okay, the other thing is, this is a 1 to 1. I have, for every 1 positive charge, I need 1 negative charge. So anytime I see this, I better have a chlorine floating around somewhere, okay? So if it's ionic, it breaks into pieces. Okay, the second thing we can look for is just something that's a molecule. So don't pick water. Is there anyone who has a favorite molecule that's maybe a simple molecule? Methane. Okay, so what if we have CH4 and we bubble that through our water? Okay, so this one we know is a molecule. It's covalent because there are no metals. Okay, and we talked about our exception with ammonia. Okay. Ammonium, sorry. No metals. So if we draw this, this isn't going to break apart. This is just a molecule. And we just have this floating around. So we have water, we have our molecule. This molecule is not breaking apart. We have 2 different types of atoms. Okay. The last option is, the last option is an acid. Actually, this one doesn't come up on this topic, but I want to talk about it right now because it does come up in the chapter, which is annoying. This is the list of acids that you need to memorize before chapter 9. But I just wanted you to have an idea of what an acid is because it does come up on another topic. But we're going to talk about it really briefly right now.
So is it the one that you said?
Okay, Corbin is going to come now, and we'll go over one topic. Does that work? Yeah.
Wait, is he still in chemistry or chemistry?
Yeah, just a different hour.
I have it.
Okay, so okay, so an acid, the other option is an acid. Okay, so an acid, we are going to look for a hydrogen in front of our formula. Okay, and what happens is the acid is going to, the hydrogen is going to break apart from the other piece of the formula. So let's look at an acid. And so that's the pattern you're going to look for. You're going to look for a hydrogen at the beginning by itself. So let's look at this one, HNO3. HNO3 is nitric acid. When I add it to water, we can get a hydrogen, and then we get the nitrate. Okay, so those separate. Does that make sense? Okay. So this doesn't come up on this topic, but it's something that we need to kind of think about, and it kind of fits with what we're doing. Okay, let's go to the topic, and then we'll talk about the lab in a minute. Okay, so imagine a small amount of each compound is dissolved in water. So the first one, what do we have? Do we have an ionic compound or a molecule or an acid? We have a molecule, so it's not going to break apart. So we're looking for nitrogen bonded to oxygen modeled in water. So let's go through. So this first one, we have 3 different types of atoms. No, we only have an nitrogen and oxygen. So that's wrong. Next one, we have 2 different ones that are bonded together. This would be, so far that's looking really great. Number 2. We're going to go over this topic and then we'll go in the lab. Does that work for you? Okay. This one has things that are broken apart. We have like this, and then we have this. That's wrong. Okay. We have also 3 different types of elements. That's wrong. Okay. This one, we have 2 different elements. They're not bonded. If it's a covalent compound, if it's a molecule, they're not going to break apart. So that's wrong. Also, our ratio is wrong. Okay. There's 3 to 1. This is 1 to 1. Okay. That's wrong because there's 3 different types. They're broken apart. This is wrong because they're broken apart. This is wrong because there's 3 oxygens for 1 nitrogen. That's wrong. And this is wrong because there's something else floating around. Okay, does that make sense? So the best answer would be this one because there's a nitrogen bonded to an oxygen that's modeled, and they're not broken apart, and it's 1 to 1. Okay, how about this one? Is this ionic, molecule, or acid? This one's ionic, metal, non-metal. So what would we expect here? Good. 2 types of elements broken apart, 1 to 1 ratio. So this is 3 elements, wrong. This one's 2, but they're bonded together, that's wrong. This one has 3 different elements, that's wrong. This one, it's 1 to 3 ratio. They are broken apart, but it's 1 to 3 instead of 1 to 1. Does that make sense? Okay. This one's wrong because there's an extra element type. There's only 2 in our model, or in our formula. So this must be it because we could say this is potassium and this is chlorine, 1 to 1 ratio. They're broken apart. That's what we're looking for. And that one's wrong, and that one's wrong. Does that make sense how we're kind of going through and matching them?
Will you go over how you know if they're broken apart?
Yes, so this is broken apart because this element is by itself.
Okay. How can you tell that
from here? Yeah, so I have a metal and a non-metal. Okay. If it's ionic, this is going to break into K+. This is going to be KL or Cl-. I don't know. Okay. Yeah. Okay, let's do another one. Okay, how about this one? Good, metal, and then a polyatomic ion. So this one will need a sodium, and then nitrate is kind of like a molecule. It's an ion, but it's covalently bonded. So we're going to need a sodium, and then we're going to need nitrogen modeled. It needs to be attached to 3 oxygens because this piece, if it's a polyatomic ion, those are chemically bonded. Those don't. The ion itself doesn't break apart. Okay. So let's look through and see what we can find. So this one is wrong because there's only 2 types of elements. We have sodium, nitrogen, and oxygen. So we need to be modeling 3 elements. This one only has 2 elements. This one has 3, but this is wrong because nitrogen should be attached to 3 oxygens. Okay, this is also wrong because the ratio is wrong. This should be 1 sodium for 1 nitrate. Okay, nitrate is a piece. You have to recognize the polyatomic ions from chapter 3. Okay, that's wrong. We only have 2 elements. This is wrong. We only have 2 elements. Okay, this is looking pretty good. We have something that looks like nitrogen with 3 oxygens, and it's broken apart from sodium so metal and then polyatomic ion, and we have a 1 to 1 ratio. So that looks pretty good. So let's go back to 6 and then This one has 3 elements, but it's not the right ratio, and we don't have the nitrogen is not bonded to the oxygens. Okay, that's wrong. And 8 is also wrong. This is just showing them all broken apart. That's not true. The polyatomic ion doesn't break apart. Okay, so let's go back to 6. That looks right. Okay, this one, CO. Is this one ionic, molecule, or acid? This one's a molecule. So we're looking for something that has carbon next to oxygen bonded together, not broken apart, should have 1 carbon, 1 oxygen, nothing else. Okay, this one is showing 2, it would be like 2 oxygens, that's wrong. So, this looks right because we have carbon attached to oxygen. Okay, let's keep going. This is showing 3 different elements, we only have 2. This one is showing the wrong ratio, they're also broken apart. That's not true for a molecule. This is showing them broken apart, which is not true. This is showing 3 different elements. This is showing 3 different elements. This is showing 3 different elements. So let's go back. This is the best one. Does that make sense? Okay. All right. So let's stop here for a minute and we'll go to the lab and finish. So I'm going to hand this sheet out to you. So this is on hard stuff. This is a table from Alex. The table is hard to use because every time you do the question, you have to open it up again, and it's just hard to read. So this is the same table from Alex. You can use this on the test if you don't write on this paper. Okay. If you don't bring this to the test, then you can use the Alex table. It's the same table. Okay. So it's nice to have it printed out because it's just easier to have a copy of it sometimes. So. And we have done this before. We did this on lab 4, so this should be a little bit of a review. Because you did this already. Yes. No, this is topic device lab 4. Yes.
She didn't like that very much.
Did you say that?
So for the 4A is
Okay. Oh, thank you. So I'm going to pull up my camera. And let's put it over here. So this type of question, again, this is like lab 4. So we're taking solution A and we're mixing it with solution B. Solution A and solution B start out as soluble. They're dissolved. And then we're going to mix them together just like you did in lab 4, and some things will precipitate. Some things will become a solid. Okay. So what you're going to do is, so this first one, you have sodium chloride and silver nitrate. The metal at the beginning is going to switch its anion. So sodium's going to end up with nitrate. Silver is going to end up with chloride. And you're going to see if either of those are precipitates. Okay? Let's walk through one. So the first one was sodium and nitrate. So let's see. One trick is that no nitrates are precipitates. So that one's probably not going to be there, but we can go through. Sodium is here, sodium Na+, and nitrate. Yes, that's soluble. Okay. Yes, it's soluble. Next one is silver and chloride. So silver is down here. Chloride is here. Silver chloride says no. If there's one that says no, you're going to put yes in this box. It's like inverse. Okay. No on this sheet means it's going to precipitate. It's not soluble. So you say, yes, a solid is going to form. A precipitate is going to form. Then we have to figure out the name or the formula of it. So we just decided that silver chloride, the formula or the chemical symbol for silver is Ag. Chlorine is Cl. We need to know how many silvers for how many chlorines. Well, we need to know the charges to do that. We just talked about chlorine is -1. Silver is one of the elements that always forms the same charge. Well, also it's on here. Ag is down here. Ag is always plus. That's always Ag plus. Okay, so that means our formula will be AgCl, 1 chlorine for 1 silver. Don't write charges in the formula. So we put yes, and then we put AgCl. Okay, next one is zinc sulfate and potassium sulfide. So zinc is gonna match up with sulfide. Potassium is gonna match up with sulfate. So let's do zinc sulfide first. So zinc, zinc, and then sulfide is here. Oh, great. No. Oh, that's oxygen. No. So yes, if it's not soluble on this sheet, then it's yes, the precipitate forms, and then we put that here. There can only be one. So we've got zinc is 2 plus, sulfide is 2 minus. So how many zincs to how many sulfides? This one's just 1 to 1, so ZnS. Or we can do this crisscross. We can say I need 2 sulfurs for 2 zincs, and then I can simplify to get 1 to 1. All right, and then the next one, let me put that, ZnS. The next one is sodium hydroxide and iron bromide. So let's look at sodium bromide. I'm going to look at sodium. Bromide is yes, that means it's soluble, not a precipitate. So let's look at the next one. The next one was iron and hydroxide. Iron, and it's iron 2, so watch out for that. Iron has 2 charges here. Iron 2 and hydroxide. Oh, it's also no. So let's figure out the formula. So no means yes, a precipitate will form because iron hydroxide is not soluble. Iron, this was iron 2 plus. Do you know the charge on hydroxide? Oh, it tells you actually. Oh, this would be a way. It gives you some of the polyatomic ions. So that's nice. Hydroxide is OH minus 1. So I need 2 hydroxides for 1 iron. So I'm going to write Fe. I need 2 hydroxides, so I'm going to put it in parentheses. FeOH2. Okay. Should we do one more? Yeah. Okay. All right, this one we have ammonium nitrate and sodium chloride. So again, the solutions that you add together, those start as soluble. So we just have to check the metal, or this one's not a metal, the cation with the other anion, the cation with the other anion. So this one we're checking ammonium chloride. Ammonium chloride is soluble. So let's check the other one. Sodium nitrate, that's also soluble. So this one, if they're both yes, then no, a precipitate won't form. They're both soluble. Let me just move on. Okay, the next question. Potassium hydroxide plus magnesium bromide. Will something precipitate? Well, is potassium bromide soluble? Potassium bromide is soluble. Well, what about magnesium hydroxide? Is that soluble? Magnesium is Mg. Watch out. This has gotten some people. We have Mg and Mn. What's Mn? Manganese. Magnesium is Mg, so don't get those flipped.
Oh, I already got that flipped.
Okay, great. So don't get it flipped. Mg and hydroxide. Mg, hydroxide. So no, that means it's going to precipitate. So we put yes, it's going to precipitate. It's not soluble. Or it is not, yeah, it's not soluble. So again, we have Mg, magnesium, plus hydroxide, OH minus. We need 2 hydroxides for 1 magnesium. So Mg, OH, 2 of those. Okay, and then the last question on this box. We're looking at potassium nitrate. So first one goes with the second one. And then silver carbonate. Potassium nitrate. Oh, well, our shortcut is that no nitrates are soluble. So, or we can look at specifically potassium nitrate, also soluble. Silver carbonate. Silver is Ag plus. Carbonate. Where is carbonate? Carbonate is CO3 2 minus. It says no. So that means it's going to precipitate. So, oh, did I just say that? These are some of the polyatomic ions. So if you can't remember them, this has a few. This is in Alex. So it doesn't have all of them, but it has a few. That would be a great place to look if you can't remember what the formula for some of these is. So we have silver was Ag plus. Carbonate was CO3 2 minus. So this is going to tell me I need 2 silvers for 1 carbonate. So my formula is going to be Ag2CO3. I think this is the first time I've seen silver carbonate on this question. Wait. Okay.
I had this as one of them was the exact same.
Okay. All right. Questions on that? We'll stop there. Oh, and then next time we'll keep going. We'll weigh the samples. We can do some of the math next time, and then we'll keep going in Alex. Okay. Alex. Oh, I have the schedule. Let me get this out to you. So I forgot. So I thought I did this, so I don't know what happened to it. This is our schedule for the rest of January. Also So Alex, chapter 8 is going to be due January 31st. So make sure you're getting Alex chapter 8 done. And then we will have the exam on the 2nd of February. So that's where we're going. Next week we'll just do Alex chapter 8 and we'll finish up lab 6. And then the following week, Monday, we'll have lab 7. So we'll talk more about that next week.
Yeah, but